Okay, now we are going to use what we went over in the previous video, which was a little longer, but it kind of went over the 6 main trigonometric functions, right? And we're going to use that to find these ratios using these numbers. Now, this is an example where they give us values for all of the side lengths, right? And so this is just basically a review of do you know these ratios, right? And so we're going to start with first of all with our SOHCAHTOA. All right, SOHCAHTOA. So we're going to start with this first one. So this means sine, right? So we're doing the sine of theta is equal to the opposite over the hypotenuse. So S-O-H, right? So right there you go. So our opposite, so we find theta, all right? Theta's right here. The opposite leg is going to be the one across from it. So you take the angle and you go straight across so you hit the leg, right? And the leg is right here. So that is going to be 8. So this, in this case, is going to be my opposite leg. All right, your hypotenuse is always the leg that is across from the right angle. So that's this right here. So this is my hypotenuse. And your adjacent is always the one that's next to your theta that isn't the hypotenuse, right? It's the other one. So that's your next, right? That's what add means besides or alongside or next to in Greek and Latin word roots. So that's what the word adjacent means, right? So we have 8 over my hypotenuse, which is 17. Now that we have everything labeled. All right, now let's start with cosine. So the cosine of theta, so that's this one right here, ca, so adjacent over hypotenuse. That's what the A and the H mean. All right, is equal to 15 over 17, right? And these don't really simplify. If they do simplify, please do simplify them. This is this is big person math. We should be able to simplify fractions. We have the tangent of theta, all right? So tangent is the opposite over the adjacent, okay? Opposite over adjacent. So my opposite over adjacent, so it's 8 over 15, right? And again, there is no way to simplify that. They do not share any factors. And those 3 are done. Now, for the other 3, right? So we got to remember we've got our cosecant, we've got our secant. I'm going to write theta with these. Cosecant, we have our secant, we have our cotangent, right? So cotangent's easy to remember because it's just like put the CO, right? Partner with tangent, if you think of what co means, right? Secant always relates to cosine, and I think in some part of my mind, I remember that even though I want this to relate to this, and I want this to relate to this because they start with the same letters, they don't. And so I think somewhere in my mind, I related the fact that, okay, secant, even though it doesn't seem like it should go with cosine, goes with cosine. And so that's how I always remember it. All right. And so these are all our reciprocal functions, right? These are our reciprocal functions. So if you line them up with the proper functions that you have here, then you should be able to just flip them, right? So the cosecant is the hypotenuse over the opposite, right? So hypotenuse over opposite, so 17 over 8, right? And you actually don't even need to look at the diagram. You can just take this and flip it, right? Your secant is your hypotenuse over your adjacent. So hypotenuse 17 over 15. If you forget that you have this over here, and sometimes you don't, so you got to still go to the diagram. And then your cotangent of theta is what you get when you do the reciprocal of tangent. So it's going to be adjacent over opposite. And so my adjacent is 15 and my opposite is 8. And what you'll notice about most of these is that all of these main 3 functions, right, are always going to give you values less than 1, right? These are all going to give you values less than 1. And all of your reciprocal functions are going to give you values greater than 1, okay? So that's worth, that's worth remembering, because if you find your tangent of something using um, using the side measures, right? And you find, oh, the tangent of theta, and you get a number, like maybe you screw up and you put the 15/8, right? Which is easy to do. Hopefully you remember, oh, wait, they said that all these three first main functions always are going to give you an answer or a value that's less than 1. And so you can use that to kind of check yourself and use that kind of as a measuring stick. Okay, so that's basically how these work. I mean, we could spend a bunch of time doing a ton of examples with you, but this is just pretty much, if you just remember these, it's just plug and chug. And then just, if you can simplify it, simplify it. If you can't simplify it, then just leave it how it is. For our purposes right now, you don't have to write these as fractions, or I'm sorry, as decimals. Leave them as fractions, actually. And then if we need them written as decimals for like problem solving or anything like that later on, we will cross that bridge and introduce that to you. So good luck with this, and I'll see you the next video. We're going to do a quick little review of the Pythagorean theorem. Okay.